Ladies and gentlemen, there are a lot of different reasons why you'd want to use WebSockets in your application, but no matter what your implementation is, there's nothing worse than dead connections, whether it's on the client or the server, right? So imagine that you have a support system, a support ticketing system, where you have a client asking help from support, and either the actual support person or the client itself drops their WebSocket connection, but neither the client nor the server realize what's happening, and that person can be sending messages all day long and never will receive a single message again, and never will actually get any of their messages sent back to them. So they'd have to know whether or not to refresh the page, which they'd have to restart the entire support process all over again, and all of a sudden you've lost a customer for life, right? So what do we need to do? We need to implement some sort of system, and the way we're going to do it is with a ping and a pong system to check and make sure that all of your WebSocket connections are still active. Let's get right into it. All right, so we're starting off with our WebSocket simple template, and you can actually grab the link to that repo in the description below. But basically, we've renamed it to be WebSocket template because after we're done implementing this heartbeat, it'll be a much more robust solution for actually starting with as a WebSocket server template. And so this is going to be our actual just WebSocket template going forward. And right now we have everything more or less in this primary index.ts server file. And so we kind of want to clean that up a little bit. So let's go ahead. We're going to create a new folder called sockets. And we are going to create a file in that folder called index.ts. And inside this index.ts, we're going to start kind of moving all of our socket implementation logic away from this file and into this file. So let's go ahead and just move those two functions, and we can export our default configure function where we're going to be passing in a single argument of type server. And we actually need to import, we actually need to add a function declaration. That'll help. And then we need to import our server type from HTTP. All right, and so in this file now, we can actually see that basically everything underneath our app.listen here is more or less WebSocket logic. So let's go ahead and copy or cut all of that out and put it inside of this configure function here. So we can remove that space. And then finally, we can import our WebSocket definitions here. So we have our WebSocket server, we have our WebSocket, and you can basically see that everything that was being done in this file is now being done in this file. So we can import the configure function. So you can call this whatever you want. We're going to call it configure sockets, and that's going to be from/sockets. And we can actually rename this as well to configure routes. And we'll just change that there. And instead of actually just declaring a variable here, we can now just call our configure sockets function. And we're going to pass in the entire return value of app.listen, which is a server. So you can see it there. And it's going to go into our configure sockets function. And then we'll be able to handle all of our configuration in this file from now on, right? And so basically what we're going to be doing is we're going to be implementing a ping and a pong more or less. So we're going to kind of check every single WebSocket every now and then. So we're going to set like an interval, and on an interval, we're going to basically ping every connection and expect to receive a pong back, right? And so there is a little bit of overhead, but the overhead's more or less worth it because you don't want dead connections. If you have too many dead connections, you're going to be bogging down your server and sending out data that just doesn't need to be sent, right? And so basically, what we're going to be doing here is that we want to define an interval. So let's just call it heartbeat interval. And generally, this is going to be something like 10 seconds. You could do anywhere between 10 and 30 seconds would be kind of typical. Whatever the maximum delay that you'd expect from a client, to actually potentially see, right? And so heartbeat interval, we could say, so we're going to do 1,000 because it's in milliseconds, and we'll just say 5 for now. So that'll be 5 seconds. And in production, I probably wouldn't do 5 seconds because that's just too often. I'd probably do something more like 10 or 15, maybe even 30, depending on what the actual WebSockets are being used for. But you can go ahead and leave it as 5 for now, just so that we can actually see it happening and we can see it working, right? And then the other thing we're gonna actually be doing is we're gonna be sending a ping value, right? So we could call it, heartbeat value, ping value. Let's just call it heartbeat value for now. And we're going to set it to 1. You could set it to something a little bit more, secretive per se. And you might actually check that, but we're basically going to be sending a 1 down, and we're going to expect to receive a 1 back, right? And it's going to be sent as binary data instead of, string or JSON data, right? And basically, that's more or less what we need to do. We could define our actual ping function. So let's call, function ping, and we're going to be passing in a WebSocket here. And then what we're going to basically be doing is we're going to be sending that heartbeat value, and we're going to be sending it as binary data. So that's going to be our ping function, sending the heartbeat value, and it's going to be sent as binary. So now what we need to do is we basically need to handle the logic in this WSS.on connection, right? Because that's when we actually get our socket right here, right? So what we want to do is that we want to actually specify that this socket is alive. Now, TypeScript doesn't like the fact that we're setting a property that doesn't exist on this WebSocket. Now, this WebSocket definition is from the WS package. So what we can do is that we can create a new folder called typings. And inside typings, we are going to create a new file called ws.d.ts. You can name this whatever you want. I like to name it the actual name of the package that we're going to be extending. So we are going to import the WebSocket from WS, and then we're going to declare the module WS, and we're going to extend the interface WebSocket. There we go. So we're going to be extending that interface WebSocket, right? That matches up here. And we're going to be specifying a isAlive property that is a Boolean. So if we go back, we can see TypeScript is happy as a clam again. And so we have ws.isAlive set to true. And the other thing that we're going to be needing to do is we're actually going to be needing to define this interval, right? So outside of this connection, we are going to say const interval equals set interval. And this interval, this function, we want to fire every heartbeat interval, right? So that's why we actually defined that heartbeat interval. And so what we're going to be doing is we're going to be looping through, similar to this message right here. We're going to be looping through our clients, but we're not going to care whether or not the ready state is open. We are just going to be looping through the clients, and we're going to be checking if it is not alive. Then we actually want to terminate that client and return. Otherwise, we are going to be setting client.isAlive equals false, and then we're going to ping using that client. So we're going to use this client to ping, basically, or ping the client, right? So we're going to ping the client, and we're going to expect a pong, all right? So basically, our pong is going to be received in message form, but it's going to be received as binary data. So what we can do is we can actually check if is binary, right? Else, we're going to loop through the clients and send the message. Now, what we can do is we can get a little bit more exact, and we can say, if it is binary, and we can just say message. Now this is raw data, so you could actually define it as something specific, but I'm just going to use any for now. But we're going to be indexing into the first spot, and we're going to be checking the heartbeat value, right? So we want it to equal the heartbeat value because that's what we're going to be sending back. And basically that's just a value of 1. And so if is binary and the data equals 1, then we're actually going to be, setting the isAlive property back to true, right? And what we can also do is we can actually log pong as well. So just so that we can actually see it happening and seeing it work, we're going to log pong. And we can also actually log here as well. We're going to probably comment these out before we check in any code, but we want to log that we're actually firing the interval, right? So firing interval. And so basically the way that this works is that we are establishing an interval, right? And every single time this interval function fires, we're looping through all of our clients, and we're checking if this isAlive equals false. Now, on connection, we're setting the value to true, right? So upon connection, we're setting it to true. And then we're checking if it's false, right? Which shouldn't happen the first time after a connection, right? And then we're setting the value to be false, and then we're pinging, right? And if we receive a pong, then we're setting the value back to be true. So we're setting it to false, we're pinging upon pong, we're setting it back to be true. And that should continue to work. We should never actually see any kind of race condition that's going to be an issue. This should continue to work indefinitely for as long as the connection is valid. Now, if the connection does drop for whatever reason, then we will terminate the connection and we will free it up from this list of clients, and we'll have one less client to actually loop through, right? So this is basically everything we really need from a server side. Now what we need to do is we actually need to implement this on the client. So let's go ahead and go to our public folder, and we'll go to our app.js here, and we're going to go ahead and kind of go through exactly what we need to implement here. But basically we need to create a heartbeat function. So we're going to create this heartbeat function, and it's going to be of type, WebSocket for now. So it's going to be of type WebSocket. And inside this heartbeat function, basically what we're going to be doing is we're going to be setting this ping timeout, right? So basically the ping timeout, well, I guess actually we don't even need the heartbeat. We don't even need, because we have WS in here already. So the heartbeat function will just be a function like this. We don't need to pass anything in. We have WS here. We're only going to have a single WebSocket at any given time. So what we want to do is we actually want to set ws.pingTimeout equals set timeout. And what we need to actually do is we need to make sure that this value is a match to our server. So what we want to say is that we want to say our heartbeat interval here equals, and we can say it's the 1000 times the 5, right? So that'd be 5 seconds. But what we really need, we need it to be something a little bit more than 5 seconds, because we need a buffer, right? So it's going to be 5 plus some arbitrary buffer. I'm going to say an additional 1 second in there. Now, obviously, you don't need this additional 1, but we want to be explicit in what we're doing here. So it could just be, the 1000. This is the 5 that we're taking, and then this is our buffer, right? Now, this math is negligible, so don't worry about slowing down your client at all. You want to do things that are going to actually look good and be able to tell why you're actually implementing something this way. So what we say is we can just say 5 plus 1 second, and that's going to be our heartbeat interval. So that's going to be our, well, let's call it heartbeat timeout, right? Not heartbeat interval. So it's a little bit different because we're actually doing a timeout here as opposed to an interval, right? So that's our heartbeat timeout. And if this timeout actually does fire, what we want to do is we want to close WS. All right. And then after that, this would basically be where our business logic goes for reestablishing a connection. So basically business logic for deciding whether or not to reconnect. And you may automatically reconnect. You may have the client have to do something to reconnect. You might pop up a modal and be like, are you still, here? And if so, reconnect, that kind of thing. But again, this is where you would do that, and you may just automatically, depending on how you actually want to implement this. So in here, we can actually check, if not WS, or so you could just say if not WS, return, else if not ws.ping timeout. That's where we actually want to clear the timeout, and it's going to be ws.ping timeout. Now I know there's some gross red squigglies everywhere. That's because our WebSocket doesn't have this property. Again, you could have an underscore property if you want to kind of keep it a little bit more protected. I don't think they're ever going to implement a value called ping timeout on the native, WebSocket. But again, you never know. You're polluting, the native object. So again, you may want to underscore it or double underscore it even. But that's up to you, right? Again, so we need to actually tell TypeScript that this is what we intend to do. And so let's go back to our typings folder, and we're going to create a new file called index.d.ts, and we're going to define an interface called WebSocketExt, which is going to extend WebSocket, and we want to create this ping timeout, which if we look at what set timeout returns, we can actually see it is a node.js.timeout. So we're going to create it as a node.js.timeout. And then when we define this, we are going to set it to be ws to be a WebSocket ext, right? So again, let's see if it actually allows us to do this. All right, so now we are setting this new WebSocket as a WebSocket ext. So now we're good to go. And everything seems to be good for this, right? So we actually have our heartbeat function. Now the second thing we want to actually define is an isBinary function, right? And it's going to be some kind of object. So this could be a generic function that will always work. But we didn't finish our heartbeat function yet. So forget this isBinary right now. We've defined our ping timeout, but I forgot after we actually define this ping timeout, we actually have to send the pong, right? So what we want to do is we want to basically do this pong function, which is more or less just creating a data array. So it can be a new uint8 array, size 1. All right, data 0 is just going to equal that heartbeat value. So we could have another const up here, just called heartbeat value equals 1. All right, you don't need to define that variable, but I think it's just good to kind of have it up there. And then we're just going to ws.send the data, right? So our heartbeat function is finished now, right? We set this ping timeout. First, we clear it if it exists, and then we reset it to be for this timeout. Now, if we don't actually ever receive a ping from the server, this set timeout function will fire, and we will close the function we'll close the WebSocket manually, right? So again, and then we may actually reestablish the connection if we need to. But we need to actually be able to check on message whether or not the data we're receiving is binary or whether or not it's a message that we want to show, right? And so for the isBinary function, we basically just want to return the if type of object equals object, right? And we're going to do a little trick here where we're going to grab the toString function of the object prototype, right? So we're going to grab this and then we're going to set the context. We're going to call it with the context of the object, right? And so it's basically going to perform a toString call on this object. And if it equals object blob, then we know that the data itself from the server is going to be binary. So if it's blob data, we know that it's going to be binary. Otherwise, it's going to be something else, right? So it could be JSON, it could be a string, depending on what you're actually sending, right? So we know we have binary data. Now we have all the tools that we need, but we need to do a few things down here. We need to actually implement something in message. We need to implement something in close, right? So in close, if our connection is closed, we want to clear that timeout because we don't need it anymore. So if not, ws.ping timeout, then we're just going to clear the timeout. All right, so we're cleaning that up. And then in message, what we want to do is we want to check if isBinary, right? Message.data. Then we're going to do something. Otherwise, we're going to show the message, or handle the message as if it's an actual message, right? Now, basically what we're going to actually be doing in here is we're going to be using that heartbeat function that we have up here, right? So if isBinary message.data, we want to heartbeat, right? And so we call heartbeat, and then that's going to pong the server, and that's going to basically keep the connection alive and keep things going, right? So if isBinary heartbeat, otherwise we've received a message. And that should be the whole implementation here. So what we want to do is we want to go ahead and we want to pop open a terminal, and we're going to go ahead and npm run dev. All right, no errors, that's good. Everything seems to be working. So let's go ahead and pull open a browser real quick, and we're going to localhost 3000. And actually, let's just open a couple localhost 3000s. All right, let's go ahead and open 3 of them. And we're going to open up a connection first and foremost. And so if we pop this back open, we can actually see that we're firing the interval and we received a pong. So that's good. Firing interval, pong. Let's go ahead and close a lot of these files real quick. And so, basically we have our console.log pong in here. And so basically you can see that we should be receiving a pong from every single client, right? And so, and actually I just noticed something. One other thing we need to do is we have this interval here, but what we haven't done is that we don't want this to fire indefinitely if this WebSocket server were to close, right? And so just to clean up the last of it, what you want to do is you want to handle the WebSocket server close function, and you just want to clear the interval. All right, so that's just a little housekeeping. And again, that's actually restarting the server should close that connection. So let's go ahead. You can actually see the WebSocket connection closed, so that's good. All right, so let's go ahead, open the connection back up. WebSocket connection established. All right, we're firing the interval every time. We're receiving a single pong here. Single pong. Now let's open up a second connection. We have 2 connections open, and now we're receiving 2 pongs. And every time we open a connection, we should receive the same number of pongs. So just to kind of make sure that that's true, we have a third one now. And upon the next firing of interval, we have 3 pongs. And let's make sure that we can actually send a message. So sent message test, received message test, received message test, received message test. Let's just sing test 2, sent 2, received test 2. This one has received test and test 2. And this one has received test and test 2 as well. So everybody's receiving the data. We can go ahead and we can check that we're still getting pong here. And we can close a connection. So if we close this connection here, we will show you that the one connection was closed, but we're still firing the interval and we're still receiving 2 pongs. We can continue firing this interval and getting 2 pongs. All right. Now, closing out is the same thing. We still have 2 connections here. Let's go ahead and just close out this browser, right? Make sure that we now have 1 pong, so that connection was closed. And so we're still firing the interval. We have a single pong still. And finally, we will close the final connection. And you can see connection was closed, firing interval, no pongs left. So the heartbeat function is working. If we did have one drop, we would automatically close that connection. We could create logic to reconnect, but everything is good to go, and you shouldn't have any problems moving forward. All right, so I hope that was easy enough to understand. I feel like I tried to kind of go step by step through it, and we successfully created our heartbeat function. And again, like I said, we have it set as 5 seconds on the template, but you may want to extend that out to be something more like 10, 20, or 30, depending on your particular use case. But it shouldn't really bog down your servers too much. It's really not that much overhead, and honestly, it's necessary because, like I said, the other scenario is that you could potentially lose a customer forever with having a very bad, support system or support ticket in general, right? So again, make sure you subscribe to our videos. If you want any future videos, we're gonna be doing more WebSocket videos in the future, making that server even better. But otherwise, if you have any additional content requests or content ideas, feel free to drop them in the comments below. We really do look at every single one of them. And check out our merch store. We have cool courses and as well as merch in the descriptions below. Just go to our website. If you want to become a full stack developer, take our full stack course. If you want to learn more about React, take our React course. Otherwise, we'll see you soon.